Next runnable I'll discuss is the runnable sequence that combines components and chains to create a sequential chain. You can either directly create a runnable sequence instance or you can use the pipe operator. The pipe operator is commonly used and you have already seen the pipe operator in action. Output from the runnable sequence is the output from the last step in the runnable sequence chain. This runnable supports streaming if all the components in the chain support it. Let me show you how you create runnable sequences. Let's start by importing the runnable sequence class. And this time I'm going to create three functions. First function is a add1 function. Then I'll create another function by the name of, let's say, multiply 2, and another function subtract 3. So these are the three functions. As the next step, I'm going to wrap these with runnable lambdas. So here is the add1 runnable, multiply 2 runnable, and the subtract 3 runnable. Now let's say we want to combine these in a sequence. So the way we'll do it is we can either create a runnable sequence directly, that is by calling runnable sequence with the three components, add, multiply, and subtract, or we can use a pipe. So the other version of the same sequence will be runnable sequence equal to, let me just copy this, paste it, and the comma will be replaced with a pipe. And so this will be our sequence. Now to test it, let me invoke this with input equal to 1. The final output should be equal to 3. Let's see if that's the case or not. So runnable sequence dot invoke, pass it 1 and run it. And as expected, the answer is 3. Next runnable is the runnable parallel that runs the components concurrently. This can significantly improve the performance of a chain. The output for each of the steps in the runnable parallel are returned as attributes in the output dictionary. This runnable waits for all the steps in the chain to finish. Let me explain it with an illustration. Components in the chain that I have depicted here are executed in parallel with the same input X. Each of the components then generate the output independently. And the final output is a dictionary with the output from each of the components in the chain. Let's check out the working of runnable parallel in code. Start by importing the runnable parallel class. I'll create a variable runnable parallel equal to runnable parallel. And now we are going to add the components that we would like to run in parallel. I'll add the first component, which is going to be a pass-through. We want the input to be passed as is. I'm going to call it original and it'll be of type runnable pass-through. So here you see we are combining runnable pass-through to get the input all the way in the output. Next one will be add1 function. So we'll use the runnable add1 runnable. The output will have a key add1 and the value returned from this function will be the value for the add1 key. Similarly, we'll have multiply and the subtract functions. Let's go ahead and invoke this chain with an input equal to 5. So here you can see the original value is 5. It is because we have defined a runnable pass through here mapped to the original. Then we have add 1, multiply 2 and subtract 3 as the attributes in the dictionary. Next runnable class is the runnable branch, which selects and runs a component in the chain based on the condition. Branches are defined as tuples. Each tuple has a condition lambda and a runnable. If the condition is met, then that runnable will be run. This class requires that you must provide a default runnable, and this default runnable will be run if none of the conditions are met. Here is an illustration that depicts a chain built with a runnable branch. The received input is passed to each of the components. The first component that matches the condition using the input variables is the one that gets selected for running. The output for that component will become the output from the chain. I'll leave the coding part for runnable branch as an exercise for you. Please go ahead, open this notebook either in local Jupyter environment or Google Colab and check out the sample code for runnable branch. In this lesson, you learned about the LangChain runnable classes. The runnable classes makes it easy to build sophisticated and flexible chains. In the next hands-on exercise, you will dive deeper into the use of runnable classes. Happy learning, and I'll see you in the next video.